Objective 8, Rational Functions, Part 2A. We had Part 1A and B, that was rational functions of a specific type. And now we're going to consider a rational function where we have a quadratic over a linear function. We handle it a bit differently, although some of the concepts carry through. So we'll have A and B. We'll have two different parts. Part A, we're going to graph. Part B, we're going to talk about limits. Well, first of all, we have 2x squared plus 3x plus 5 over x minus 2. We have something called a slant asymptote, which we find by, we want to divide this out using synthetic division. And we're going to divide 2 into 2, 3, 5. And so bring down the 2, multiply, add, that's the remainder. What happens is this function, we can rewrite this as 2x plus 7 plus 19 over x minus 2. And as x gets large, this fraction gets smaller and smaller, and the function looks more and more like this linear function, 2x plus 7. So the slant asymptote is y equals 2x plus 7. Okay, you just ignore this remainder part. Now the vertical asymptote, same technique, we will set x minus 2 equal to 0, and we get x equals 2. There's our vertical asymptote. Now we're going to make a table, and the table largely is going to define the scale on the x and y axes. X equals 2, that's still our central value. And we're going to, that's undefined there. If you try to find f of 2, you have division by 0. Then we're going to go up, 1, 0, negative 1. And then we're going to go forward, 3, 4, 5. Simplest thing to do is plug into this form of the function right here. And let's plug negative 1 in. We get 2 times negative 1 plus 7 plus 19 over negative 1 minus 2. That's 5 plus 19 over negative 3. That's actually 6 1/3. We have minus 1 1/3. 5 minus 6 1/3. So I'll just use this scratch pad here. Now on to 0, plug in 0, 2 times 0 plus 7, plus 19 over 0 minus 2, 7 minus 19 halves, 7 minus 9 1/2, minus 2 1/2. Substitute 1, 2 times 1 plus 7 plus 19 over 1 minus 2. 9, and that's minus 19, so we get minus 10. You can tell which way this is headed. And we can skip over 2. We go to 3, 2 times 3 plus 7 plus 19 over 3 minus 2. 6 and 7, 13 plus 19, 32. Okay, and plug in 4, 2 times 4, 4 minus 2, and let's see, 8 and 7, 15, plus 19 halves, that's 9 1/2. I guess we get 24 1/2. Substitute 5. And let's see, 10 and 7 is 17, plus 19 thirds, that's 6 1/3, so we get 23 1/3. So y has to go from negative 10 up past 30. I'll use a scale of 5. 5, 10, 15, 20, 25, 30, 35, 10, 20, 30. needs to go down to negative 10 and beyond. X has to go from negative 1 to 5. We're going to use a different scale, negative 1, negative 2, negative 3. 1, 2, 3, 4, 5, 6. Okay, now we need to graph the asymptotes. X equals 2 is easy. That's just a vertical line right here. The slant asymptote, a little more complicated. The simple way to do it is just plot a couple points. At x equals 0, 0 plus 7 is 7. There's 5, that's right about here. And pick a number like 4, for instance. You plug 4 in. Y is 2 times 4 plus 7, which is 15. And so at x equals 4, we have to go up to 15. That's right about here. And then we can, if you have a straight edge, that will work. A straight edge on a piece of graph paper. So we have two asymptotes. You see why it's a slant asymptote. Okay, the best thing to do is pick 2 points far apart. If we picked a point here and a point here, a lot easier to mess up the accuracy of the line. So make sure it's spread out. So quite a bit. I could have used 5 or 6. It would have worked equally as well. Now we're going to plot these points. Negative 1, negative 1 and a third. Negative 1 is right here. Negative 1 and a third is down here. That's 5, keep in mind. 0, negative 2.5. And at 1, we're at negative 10. We're down here. You see, you can see this compartment here, and we're rounding the corner. It has to head toward that asymptote, round the corner, head toward that asymptote. Make sure you don't like head toward it and come away. And then 332, we go over to 3 all the way up to 32. That's pretty high there. And at 2, we have 24.5, or at 4, we have 24.5. That's 25 right there. So it's just a little under there. Hard to be precise when you don't have lines, but at 5, we have 23 1/3. It's just a little bit below. You can see what happens. We're rounding the corner here. And we're drawing our graph. We can label these graphs. This asymptote, y equals 2x plus 7. And this asymptote is x equals 2. And that's how we draw the graph. There's really not much more to it than that. The tricky part is getting the scale right on here. We'll be back with part B. We'll talk about limits.